Hello, welcome to our tic-tac-toe project. We're Team R5, Nathan Pockton, Cragen. We have two separate logic trees, one being for if the computer goes first, and the other one being for if the computer's opponent goes first. If the computer goes first, its first move is going to be the corner, which is the best move that you can do on the first turn. And then every move after that, it will check for a winning move, which means that it checks if it has a winning move available, and if it does, it'll go in that spot. And then it'll check if it doesn't have a winning move available, it will check for an opponent's winning move, which means it'll check if an opponent can make a winning move in the next turn, and if it can, then it will block that. And then it checks the corners, and if there is a corner available, it will take a corner space, and then it will check the sides, and if there's a side available, it will take a side space. And then at the end, it will check to see if the center is empty, and if there's an empty center, then I'll take it. So while we were doing this, we ran into something called forks, which is where two adjacent sides are occupied by the opponent, which means that if the opponent goes in the corner next to these sides, then he will have two options available for victory. So it's impossible for us to win in that situation. So we wrote a function that will check for these forks, and if there's a fork, it will go inside the corner to block the opponent from going inside of the corner. If the opponent goes first, then the computer's first move will be to play the center if the opponent plays in the corner. And then after that, it will follow these steps. It will check for a winning move, and if there's no winning move, it'll check for a block, and if there's no block, then it'll check for sides. If there are no sides, then it'll check for corners. Here we prioritize the sides over the corners, because if you go in a cross, then you will be more likely to win. And then if the opponent plays the center, then you're just going to go by the decision tree shown in the previous slide. Scanning the board and placing the marker. Every move, our program will go through these 4 different things. The first, after it checks and finds the perfect move, we have a function that will direct the robot to place a marker. The function accepts coordinates and will place a move where those coordinates say to place the move. And then we have a function that scans the board and places all of the occupied spaces and the information about the board into a matrix that we made. We made this function using a for loop, and then another function will initialize the robot, and then a final function will check for a winner. And if there's a winner, it'll display a message that tells you who the winner is, and it will ask you if you want to play again. After which it will reinitialize, and then you will play again. After this, I'll have 2 other videos about the robot, or that show the robots playing a game against each other, or playing a game against itself, and then playing a game against a human.